Hello everybody, welcome back to another Maths Made Easy YT video. Today we're going over a circle theorems questions past paper thing. So if you're struggling with circle theorems and you want to see how I would approach these problems, you can see this. I haven't looked through the questions before, so it's gonna be a real time like what I'm thinking, how I would approach these questions. So this one, I'd read everything carefully. It's pretty important. I want to see which angle you're looking at. So here, A, B, C, and D are points on the circumference of a circle. Angle ABD equals 54 degrees. Angle BAC equals 28 degrees. Find the size of angle ACD. This angle over here. Okay, so here we can use the circle theorem that angles in the same segment are equal, as this angle ABD is in the same segment as ACD. You can see that from kind of like this bow tie shape that happens. So it would be 54 degrees. Give a reason for your answer. Well, the reason is angles in the same segment are equal. It's kind of shitty writing, but in the same segment are equal. So yeah, that's all you need to write for these give a reasons. Basically just like which circle theorem you're using basically. Here, A, B, C, and D are points in the circumference of a circle. So here we have A, B, C, and D. Angle AOC, circumference of circle center O. So O is the center. That's 168 degrees. Work out size of angle ADC. You must give reasons for your working. Okay. So the first thing we know is that the angle of the circumference is half the angle at the center. So angle ABC, that is 168 over 2, which is 84 degrees. So I'll just annotate that here. 84 degrees. Then we can use the fact that this is a cyclic quadrilateral. So the opposite angle, which we're trying to work out, ADC, it's going to be 180 minus 84. So actually, I'll just write... actually, I'm not going to write the reasons because it's kind of hard to write on this tablet thing. But yeah, I'll say the reasons is because angle at circumference is half the angle of center, so you would just write that in brackets and just write that and then that here. So angle ADC is going to be 180 minus 84, which equals to 96. I apologize for this really bad writing. I don't know. I don't even think it's a tablet. I think this is software, but whatever. Here we have 96 degrees. This is because opposite sides in the cyclic quadrilateral add to 180 degrees. So yeah. A, B, and D are points on the circumference circumference of a circle center O. So we have A, B, and D. BOD is the diameter of the circle. ABC and AC are tangents to the circle, and angle OCB equals 34 degrees. Work out the sizes of angle DOA. So it is this angle we're trying to work out over here. So there's a few things we can immediately say. Because these are two tangents coming from the same point, these two angles are the same. So this is 34 also degrees. Next, we can also say that since these are two radiuses because they're coming from the center going to circumference, and these are tangents, these would be 90 degrees. And because of that, we can just use if we take this whole quadrilateral over here, we can say that because the angles in a quadrilateral have to add up to 360, that this angle over here, AOB, is equal to 360, that's a 360 minus 90 minus 90 again because of these two 90-degree angles, and then minus these two 34s, so minus 68. So that's going to be angle AOB. And if you put that all in, that would be 112 degrees. So this would be 112 degrees, this part only. Then what we're trying to work out is this part. And since we know that DOB is a straight line because it's the diameter, that means this plus the 112 degrees will give you 180 degrees, which means we can just do angle DOA is equal to 180 minus 112, which equals, let me think for a second, 68 degrees. Oh, so that's kind of cool, is what we got over here. But yeah, it'd be 68 degrees. Here, B and C are points on a circle centered. Oh, A, B, and AC are tangents to a circle. Angle BOC equals 130 degrees. Work out the size of angle BOA. Okay, this is okay. Here, AC and AB. Okay, here, this angle over here, I don't know what's in that, is 130 degrees. Okay, we have to work out the size of BAO, the size of that angle. So if we draw a line from O to A, it's this angle we're trying to work out over here. Okay, so first thing we can see is that these are radiuses to a tangent, so 90 degrees. Next, we know that these two triangles over here are going to be congruent because these two sides are the same, and this angle is the same. Which means we also know that each of these angles is going to be the same. Which means each of these angles is just going to be 130 split into 2. Which means each of these is going to be 75. Okay. Then we have a triangle over here, which means that the angle BAO is just going to be 180 minus 75 minus 90, which is 15. So it's going to be 15 degrees. So that's pretty cool. Here, A and B are points on the circumference of a circle center O, A and B. PA and PB are tangents to a circle. Angle APB is 86 degrees. APB. Work out the size of angle marked X. Okay. So what I would do is, it's kind of a lot of the same thing here. A lot of these tangent questions, radius tangent, but this is 90 degrees and this is 90 degrees. This is a quadrilateral, so it has to add up to 360 degrees, which means you can get this angle. What? Okay, I might actually crash out. The technology is not working to my favor. But anyways, this is going to be 360 minus 90 minus 90 minus 86. This very bad handwriting. But that's going to be angle AOB. Angle AOB. And then what that will be is 94 degrees. No. 90, 86. Okay, this is drawn very inaccurately. That's why I was questioning it. But yeah, this is 94 degrees. It does not look like 94 degrees because that does not look like 86 degrees. But whatever. Now we have this is 94 degrees. We can focus on this triangle AOB. This triangle specifically. This triangle is going to be isosceles triangle because these are two radiuses over here. These two radiuses are the same length, which means it's going to be isosceles. Which means this x over here is going to be the same as this angle over here. So we can also label that x if we want. Which means x plus plus 94, all of them together is going to equal 180 degrees, or let's call it 180 degrees equals 94 plus 2x. And then we can just subtract 94 from both sides to get 86 equals 2x. And we divide both sides by 2 to get 43 equals x. So that means x is 43 degrees. Pretty cool. Here, R and S are 2 points on the circle, center O. My bad. TS is a tangent to the circle. Angle RST equals x. Prove that ROS, this angle over here, is equal to 2x. You must give reasons for each stage working. I'm not going to write them like each stage of my working because there's not even enough space here anyways, and I cannot write on this. But I'll basically tell you the general thing. Let's imagine there's a certain point out here, P, right? And we draw 2 lines over here. 2 straight lines, not like this, but like here. From R, there's SP and RP. Then if we have this angle SPR, because of alternate segment theorem, this has to be equal to x. Then we can use the fact that the angle at the circumference here is going to be double the angle at the center here. Okay, this is 2x. So first we know that our RPS is going to be equal to x because of alternate segment theorem. Then we know that SOR is going to be double SPR, or 2x, because of the fact that the angle of the circumference is always going to be half the angle at the center. Yeah. Here, in the diagram, O is the center of a circle. A and C are points on the circumference of the circle. BCO is a straight line. BA is a tangent to the circle. AB is equal to 8 centimeters. OA is equal to 6 centimeters. Explain why OAB is a right angle triangle. That's very simple, because the angle between a radius and a tangent, I'm just going to write radius plus tangent equals 90, or the angle between a radius and tangent equals 90 degrees. Tangent equals 90 degrees. Work out length of BC. Here you would use Pythagoras' theorem. So if we put BC as, for example, we just use that C, because a squared plus b squared equals c squared. So you have c squared equals a squared, which would be 8 squared, plus b squared, which would be 6 squared. And you get c squared equals 64 plus 36. C squared equals 100. Then we can square root both sides to get c is the square root of 100, or c equals 10. And then what we get is that BC is 10 centimeters. That's pretty simple. A, B, C, and D are points in the circle center O. BC is equal to CD. Angle BCD is 130 degrees. Write down the size of angle BAD. Give reason for your answer. Okay, very simple. This is a cyclic quadrilateral because all of the points are on the circumference of the circle. And this is the opposite angle to BCD. So angle BAD is going to equal 180 minus 130, which equals 50, because of cyclic quadrilateral, opposite angles in a cyclic quadrilateral, blah blah blah. Here, 50 degrees. Work out the size of angle ODC. ODC, okay. Give reasons for your answer. Well, now we know this to be 50, right? BOD is going to equal 100 because the angle of circumference is half the angle of the center. And now we have this. You can see that these two are equal to the same, right? And these two equal the same. That means you could kind of split this up into 2 isosceles triangles. The first one, and we would use like a, what is this? My days. Okay, but if we had a straight line from B to D, right? We split this up into 2 isosceles triangles, right? So the first, for the top one, I'll just redraw here. B, D, O. This is 100 degrees. And since these two are the same, we can just do 180 minus 100 to get 80, which means these two together must equal 80. And we just divide them by 2 because they're the same, right? So we get 40 for each one. This is so annoying, bro. Yeah, 40 for each one. So these two are 40. And we can use the same logic for the bottom isosceles triangle to get these two together is 180 minus 130, which is 50, which each one would be 25. Which means ODC in total would be this 40 degree angle plus this 25 degree angle to get this 65 degrees. You would probably do your working more neatly and put like the reasons in brackets and all that, but again, the technology is failing me. Here, in diagram, A, B, C, and D are points in the circumference of circle, center O. Angle BAD 70 degrees, angle BOD is X degrees, angle BCD is Y degrees. Work out the value of angle X. That's going to be double that because the angle of the circumference is half the angle of the center, 140. And that's what you write here. The angle of circumference, blah, blah, blah. Value Y, here would be cyclic quadrilateral, would be 180 minus 710 because, cyclic quadrilateral, opposite angle, cyclic quadrilateral here. The diagram shows a circle, center O. A, B, and C are points in the circumference. DCO is a straight line. DA is a tangent to the circle. Angle ADO is 36 degrees. Look at the size of angle AOD. Well, because this is a radius, this is a tangent, this is 90 degrees, and then we can just do 180 minus 90 minus 36 to get 54. Yeah, 54. I probably made like some sort of like calculation error in this video. Just don't mind, I guess. Work at the size of angle ABC. I mean, again, I'm going. This is my first time doing it. I haven't seen it before. Okay, what is it? Angle ABC. This angle over here. Well, this is kind of like a tricky one, I guess, that sometimes people don't notice, because this is actually the same as if you had a circle near the center, and it'd be the angle of the circumference is half the angle of center. This is the angle of circumference, is the angle of center. But usually this point is like all the way over here, so it's nice and easy to see. But here it can get kind of confusing. But this is something you gotta remember when these lines intersect. You just gotta pay attention to that. This is still the angle of the circumference, and this is still the angle of the center, which means this would be 54 over 2, or 27 degrees. And then you write angle of circumference is half angle of center, blah, blah, blah. Here, B, D, and E are points on a circle, center O. A, B, C is the tangent to the circle. B is diameter. Angle D, B, E is 35 degrees. Find the size of angle A, B, D. Okay. Because the B, D, E is angle inscribed in a semicircle, because BOE is a diameter, this would be 90 degrees. That's one of the circle theorems you have to know. Which means this angle over here is going to be 180 minus 90 minus 35, or 55. And because of alternate segment theorem, these two angles are in alternate segments, which means they are the same. So those are two circle theorems you need to know. So first you would say angle BDE equals 90 degrees because it's inscribed in a semicircle. Then you would say that angle DEB is 55 degrees because it's angles in a triangle. And then you'd finally say angle ABD is 55 degrees because of alternate segment theorem. So we get 55 degrees. Find the size of angle DEB. Oh, we already did that. So yeah, I guess. Oh, then they probably wanted us to find this out. Oh yeah, the way that they wanted us to find out is because this is radius, this is tangent. 35 minus 90 to get 90 minus 35 to get 55. So we kind of went the long way around, but yeah, this would also be 55 already. There's multiple ways to figure these things out usually, so yeah. Here. P, Q, and T are points on the circumference of a circle center O. The line ATB is tangent to the circle at T. Angle ATP equals 58 degrees. Calculate the size of angle OTQ. Give a reason for each stage of your working. Okay. For my question, which angle we're trying to find? OTQ. Okay. First of all, this is a radius. This is a tangent, which means this whole thing is 90 degrees, which means this part specifically is going to be 90 minus 58, which is equal to 32. So this is 32 degrees. Now, because we know this is 32 degrees, we also need to find out the whole thing over here. Now, because of, I'll actually just delete this part. So we have 32 degrees for this part over here. Then what we will see is that this angle and this angle have to be the same, right? Because of this isosceles triangle, right? And we know that we can use alternative segment theorem. There's actually two ways we can use alternative segment theorem. Either move this up there or move this down there. I'll just move this up here to get 58 over here. Alternative segment theorem, this is equal to 58 degrees because this is equal to 58 degrees. Then we can find out the size of these angles by doing 180 minus 58 to get 122. So these two together have to add to 122. Because they're the same, you can just do 122 over 2 to get 61, which means each one of these in total is 61, and then this whole thing is 61, right? But this part on its own is going to be 32, which means the angle OTQ, which we're trying to find, this part, is going to be 61 minus 32, or 29. Is it 29? Yeah, it's 29. 29 degrees. Let me see how much more there is. This is a little long. Okay, there's only 2 more questions. That's fine. Here, D, E, and F are points on the circumference of a circle center O. Angle DOF is 130 degrees. Look at the size of angle DEF. That's going to be 75. Angle of circumference is half angle at center. Diagram, angle A, B, and C are points of the circumference of a circle center O. Angle ABC is 85 degrees. Look at the size of angle marked X. Same thing, but in reverse. So you would multiply this to get 170. Same reason actually. And then here, you can see how like over this video I'm progressively putting less and less effort in. It's kind of funny. Okay, here, 5 more question. S and T are points in the circumference of a circle center O. PT is a tangent to the circle. SOP is a straight line. Angle OPT is 32 degrees. Work out the size of angle marked X. Give reasons for your answer. Okay, the first thing I notice here is this 90-degree angle. And then because of the 90-degree angle, I noticed that we can work this out. It'd be 180 minus 90 minus 32. This is a triangle. And then you would get 58. This would be 58. And then this would be 180 minus 58, which would be 122. Yeah, 122 degrees. And because these are both radiuses, this is an isosceles triangle, which means we would do 180 minus 122 to get 58, which means these two are going to be the same, first of all, and they have to add together to give me 58, which means each one individually is going to be 58 over 2, which is 29. Which means angle X is going to be 29 degrees. Yeah, in an exam, you should definitely like write your working out. I'd also do that. It's so hard with this. But this is like a new type of video. where I just go through something. I did no planning. This is the first time seeing this. I don't even know if these things are correct. But yeah, it just shows you how I would, work this out, or like what goes through my head. I mean, I don't know if this was useful to you, but it was, I guess, kind of fun to make. I like explaining what's going on in my head sometimes. So, like and subscribe and comment and all that good stuff. Bye.